Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. Today, we are covering Lesson 116 in Edition 2 and Lesson 104 in Edition 3. So just knowing which book you're in, this is the next lesson in my textbook. In Hannah's textbook. So basically, I got a little bit behind because I had my youngest daughter got married this past weekend. Weddings are a lot of work, and I got a little bit behind on my videos. But now it's time to catch up. I've got spring break here, and so I'm going to catch up on all my videos and hopefully catch up with wherever you are on your lessons. So we're talking about triangles and measures today. And we have three basic types of triangles classified by their angles. If we have a right angle, and remember that a right angle is 90 degrees. If we have a right angle in a triangle, we call it a right triangle. If we have one obtuse angle, and obtuse means larger than 90, larger than 90 degrees. So it's bigger than a right angle. If we have one of those, then we call it an obtuse triangle. And if every single one of the angles is less than 90 degrees, then we call the triangle an acute triangle. So if one angle is right, we call it a right angle, right triangle. If one angle is obtuse, we call it a obtuse triangle. And if all three are acute, that means none of them are right or obtuse, then we call it an acute triangle. So those are basic categories of triangles. So now we're going to talk about sides of triangles. So those were angles of triangles, and now we're going to talk about sides and how to categorize our triangles according to size. So here, a scalene triangle has all three sides different. Now, when we're looking at triangles, we put a little hack mark on our triangle to denote similarity. So if all three of the sides have different hack marks, then we have three different sides. And that is called a scalene triangle. So you're going to learn a lot of vocabulary in this section. Okay. If we have none of the sides the same, then no angles will be the same. Okay? None of the sides are the same, therefore none of the angles are the same. The next one we're going to talk about is isosceles. And the isosceles triangle has two sides that are the same, so they have the same hack mark, and then one side that's different. So isosceles is two sides equal and one side different. Now, each one of these designations has to do with sides, but sides and angles go together. So, since these two sides are the same, these two angles will also have the same measure. Opposite angles. So the two sides that are the same on an isosceles triangle will have opposite angles also, equal in measure. And the last big category that we're going to talk about is equilateral triangles. Notice that all of the hack marks are the same, which means that it has three sides that are the same, which means that it has three angles that have exactly the same measure. Equilateral triangles have three equal sides and three equal angles. Okay, so here we have an example The sum of the measures of all angles is 180. Now that's not an example, that is our rule. And that rule goes for every triangle you will ever come in contact with. The sum of the measures of all the angles is 180 degrees. So now, let's look at this one. We have 20 degrees and 130 degrees. So how many degrees must be in this triangle? 20 plus 130 plus something must equal 180. Since this is 150 put together, this one must be 30. Because 20 plus 130 is 150 plus 30 is 180, and all triangles have 180 degrees. Okay, so this one, we have a 60 degrees and a 40 degrees, and this is our unknown angle. So we have 60 plus 40 plus something is 180. 180 is 40 plus 60 plus something. Since these two add up to 100, this one must be 80. 100 plus 80, so this is going to be 80 degrees. And it is truly just as easy as that. Okay, here are our last examples on this set. So here we have a triangle, and we have a 50 and a 45 and a something. We don't know what the measure of angle B is. So the question is, what is the measure of angle B? So what we need to know is, remember, there are 180 degrees. 50 plus 45 would be 95 degrees. So what is 180 minus 95? Well, we need to come over here, and 10 minus 5 is 5. 17 minus 9 is 8. So this angle right up here is 85. And it is as easy as that. This one down here, they said that B is 110. Now, we do know something. We know that these two sides are the same because the hack marks are the same. Because the hack marks are the same, we know the opposite angles are also the same. So what we're going to do is take 180, take away the 110. So 180, take away the 110, because every triangle has to have 180, will be 70 degrees left over. But we have two equal triangles to split the 70 degrees into. So 70 divided by 2 is 35 degrees. So this angle is 35 degrees, and this angle is 35 degrees. Okay, we have 4 quick practice problems. So these are your first two, A and B. So here in A, we're supposed to find angle A, and in B, we're supposed to find angle B. So what information do we have here? We have a 40 and a 50 and a something. So 40 plus 50 is 90. If we only have 180 in one triangle, 180 minus 90 leaves us 90. So what should we put here? We should put the right angle mark. Probably should have drawn that looking a little bit more like a right angle, but it has to be a right angle, doesn't it? Close enough. Okay, it has to be a right angle because I have to have all of my degrees add up to 180. Can you see the picture there? All right, so now this one right here is example B. We have a square, which means it's 90 degrees, and we have a 30. So 90 plus 30 is 120. We need 180, so we subtract. We have 60. Therefore, B must be 60 degrees. Look how easy those are. Every triangle must add to 180 degrees. I was wrong. This is our last problem. We didn't have 4. We only had 3. Angle M is 50 degrees. So we can go ahead and label angle M 50 degrees. Now look very closely. What else do we know? All right, try to do this one on your own. Pause your video and find angle D and angle E, and then come back and see if you got it right. Okay, so since this is a 50 and these two have the same hack marks, that means they are the same length side. So opposite the hack mark and opposite the hack mark will be two equal angles. So if we have 50 for one of our angles and we know the other two angles must be the same, we can figure it out, can't we? So we have 180, take away the 50 that we already know is spent on this angle, and we get 130, but that's got to fit into two equal angles. So we divide 130 divided by 2, and we get 612,105. 65. So this is 65 degrees and 65 degrees. And we are done with this lesson. And this is Mrs. A. And may God bless your day.